and welcome to this video tutorial on modeling security risk using graphs. The tutorial is targeted to security professionals as well as anyone is interested in knowing more about security risk modeling.
This tutorial will give you the basics to model security risks using graphs. We will first introduce you to a graphical approach based on UML to identify, communicate and document security risks. We will also explain you how to evaluate security risks. Let's get started with the UML-based approach to model security risk. The UML-based graphical notation uses a set of standard concepts used in security risk analysis. A threat is the potential cause of an unwanted incident. A vulnerability is a weakness or a flaw that may be exploited by a threat to cause harm or reduce the value of an asset. A threat scenario is a chain or a series of events that is initiated by a threat and that may lead to an unwanted incident. Unwanted incident is an event that harms or reduces the value of an asset. An asset is something for which a party assigns value and is for which the party requires protection. The likelihood is the frequency or the probability of a threat scenario or an unwanted incident to occur. A consequence is the impact of an unwanted incident on an asset in terms of harm or reduced value of the asset. A treatment is an appropriate measure to reduce the risk level. Each concept is graphically represented as a UML class. Each class is denoted by a box, which contains two parts. The top part specifies the name of the security concept, for example if it's a threat or a vulnerability. The bottom part contains the name of the instance of the concept. For example, if the class denotes a threat, the name will be something like customer, hacker, or employee. If the class represents an unwanted incident, the likelihood of the unwanted incident is specified in the bottom part of the box with the unwanted incident name. Here there is an example of risk model representing the UML notation. The threat customer initiates two different attack scenarios. The first scenario is that the customer exploits vulnerability, lack of compliance with terms of use to initiate the threat scenario customer share credential with next of kin. The second scenario, the customer exploits instead vulnerability negligent customer to initiate the threat scenario customer keeps credential on post-it notes, which leads to the threat scenario credential revealed to a third party. Both scenarios lead to the unwanted incident authorized account login, which impacts the asset integrity of account data and user authenticity. The risk of the unwanted incident unauthorized account login is given by the likelihood that it occurs and the consequences that it has on the assets, integrity account data, and user authenticity. The likelihood of the unwanted incident unauthorized account login is the label of the unwanted incident itself. The consequence is specified instead by the arrow that link the unwanted incident to an asset. To reduce the risk, we need to mitigate these two threat scenarios. The first one is mitigating by the treatment regularly informed customers of terms of use, while the second one is mitigated by the treatment informed customers of security best practices. Now let's see how we can evaluate the security risk level of a threat scenario in terms of likelihood and impact. A risk value of an unwanted incident of a threat scenario is computed based on the risk evaluation metrics. The metric has on the rows the possible value that the likelihood can assume, while as a column the possible value that the consequence can assume. The entry of the metrics represent risk values. Risk values denoted in green are risks that can be accepted. Entries denoted in orange are risks that need to be monitored, while red entries are risks that need to be treated. So for each of these risks, we need to identify a treatment to reduce the level of risk down. Now let's introduce the scenario that you will analyze during the experiment. The online banking scenario focuses on the online banking services provided by Poste Italiane to their customers. Customers can access their bank account information through the Poste Italiane application or through the Poste Italiane mobile app. Customer can perform operations like checking their mobile balance, checking their credit cards, or topping up their mobile phone. The assets to be protected in this case are the integrity of account data, including personal information and account balance information, user authenticity, which means that the person that is logged as a user is identical to the user, confidentiality of customer data, which protect personal information and on-bank information from unauthorized access, and availability of service, which requires the online banking service to be available 24/7. This concludes the tutorial on modeling security risk using graphs. Thank you for your attention.